Okay, so this is day 3 in Integrated Math 1. Today our theme is solving equations still. Yesterday we learned about the rules about how to solve equations, and we learned about 4 different properties. Turn to your neighbors and remind them what were the 4 properties we used yesterday or learned about yesterday. Ready? Go. Okay, what are the 4 properties? What's the first one? Not just addition, that's an operation, but it's addition, property of
equality.
Okay, good. What's the first property again?
Addition, property of equality.
Good. Second one. Good. Next one.
Subtraction.
Multiplication, property of equality. What's the third one? And then the last one's division, property of equality. Okay? Good. So those are the 4 rules, and that's when we add the same thing to both sides, or subtract the same thing from both sides, or multiply both sides by the same amount, or we divide the same number into both sides. Make sense? Yes? Okay, cool. Very good. So next thing we're going to do today, we're going to actually, this is our objective. Let's read this out loud. Ready? Begin. I can apply and justify properties of algebra to balance an equation. Okay, good. So we're going to apply and justify properties of algebra to balance an equation. Okay? So these are the steps. If you're on the video, which I'm recording right now, you write these down. Pause right now before we move on. And then here we go. So, okay, so numbers 1 and 2. Eyes up here, pencils down, okay? So the first one is 3x minus 2 is equal to 6. I want to solve this, okay? So I want to figure out what's my variable. In this case, my variable is x, and I want to figure out how do I get x by itself. We say isolate the variable. Isolate means, keep it by itself. So I notice it says 3x minus 2. So the first thing I want to do is ask myself, how do I undo all the orders of operations? It's kind of like I have to go backwards on orders of operations. So instead of PEMDAS, I want to do backwards, which I'm going to start with subtraction first. So I want to write the orders of operations backwards. So subtract, add, divide, multiply, exponents, and parentheses, okay? So I want to go backwards. Instead of going PEMDAS, we're going to go backwards, okay? Yeah, SADMAP, that's what I call it. That's awesome. So we got 3 times x, and, are you dabbing? Oh, I thought you were like, okay, my bad. 3 times x minus 2 is equal to 6. So I want to know, are there any subtraction signs by the x? Yeah, there's a minus 6. So I want to do the opposite to undo it. All right, it's up here. So what's the opposite of minus 2? Plus 2. So I'm going to add 2 to both sides. And I think about yesterday, what's the property that I use when I add the same thing to both sides? Addition, property of equality. So then I would write that on the side. This is the addition, property of equality. This is us justifying our work. So addition, property of equality, I'm writing this down, and then I bring down the rest of the problem. 3x comes down, negative 2 plus 2 cancels out. Bring down my equal sign, and then 6 plus 2 is 8. Okay? Pretty easy so far, right? Then I know I checked my subtraction signs. Are any addition signs? Are there any division signs here? No. Multiply. Yeah, there's a 3 times x. What's the opposite of multiplying by 3? Dividing by 3. So I'm going to divide both sides by 3. Okay? The 3's cancel out, and I know that I use the division property of equality. So then I'm going to write that down to justify my answer. Okay? There's only 4 properties, but when you do the same thing on both sides, you're going to write that down. Then we're going to bring the problem down. 3 divided by 3 cancels out, so all I'm left with is x. Okay? And then I bring down my equal sign, and then 8 divided by 3 is still 8/3. We could leave that as a improper fraction. And we're done with number 1. Okay? So what did I do again on number 1? The first thing I did, look at my steps. I want to isolate the variable. So I'm looking at my x and I'm isolating. I'm thinking, how do I get that by itself? Then I'm going to undo the operations with SADMAP with their opposite operation. So we had minus 2, so the opposite of minus 2 is plus 2. So I added 2 to both sides with the addition property of equality. Then I divided both sides by 3 with the division property of equality. And then I got my final answer. Make sense? That's number 1. Watch one more time. Pencil is down still. Number 2, we got 1/2 z plus 4. Again, I'm using STADMAP. I identified my variable, isolated, it's the z. So 1/2 z plus 4 is equal to 10. So the first thing I want to do is subtract 4 from both sides. So we have 1/2 z is equal to 6. I know that I subtracted 4 on both sides, so I know I use the subtraction property of equality. Then I'm going to, I notice that it's saying 1/2 times z, so I want to divide both sides by 1/2. So I have to divide by 1/2. So when I divide a fraction, what am I really doing when I divide a fraction? Who remembers? I multiply by the reciprocal. Remember that? So what's the reciprocal of 1/2 when we flip the fraction? 2. So I'm really multiplying both sides by 2. Or 2 over 1, which is the same number, okay? So the 2's cancel out on the left. And so do the 1, so I'm left with z. And then 6 times 2 is 12 over 1. And I can simplify that, and that's 12, right? And then I know that I use the subtraction property of equality and the multiplication property of equality. Okay? Pretty straightforward. Raise your hand if you've seen this before. You've done this before. Okay, good. A lot of you have. That's okay if you haven't. We still need to make sure you know it when we start off this year. All right, any questions on numbers 1 or 2? Okay, so what I'd like you to do is take a moment, talk to your neighbor. Let's keep going here. Number 3. Oh. Okay, so number 3, we have Tanner. We're good to go. Let's see. End of the period. Okay. Okay, so 5x minus 10 equals to 20. Let's put this on the whiteboards, and we'll start this one off together. What do you think you're going to do first? Turn to your neighbor and explain what operation you would do to both sides first. What are we doing first, everyone? Adding how much? 10 to both sides. Okay, so we got 5x minus 10 equals 20. We're going to add 10 to both sides. And what property is that, everyone? What? Good. Addition property of equality. Okay. So we're going to bring down the 5x and bring down the is equal to 20 plus 10, which is 30. Okay, finish up this problem for me. 20 plus 10 is 30. Oh, okay. You made a mistake. Okay. Finish it up and box your answer. I'm going to check up on you in 10 seconds. Is x is equal to 6, right? We want to divide both sides by 5. What were the two properties we used here, by the way? What are they?
Addition property of equality.
Good. And? Property. Good. Okay, you had to say all 4 words. That's what the properties are. Good. If you want to wipe things down, you could use the floor too, or the, or you could use the side of your, the floor is just fine for you. Okay? Awesome. Okay, next one. Number 4. Turn your neighbor, and I want you to predict what are the two properties you're going to use. Turn to your group and tell them what two properties you're going to use to solve this before you start. Okay, and work this out yourselves. Ready? Go. So on this one, we're going to subtract 5 on both sides on number 2, or 4, I'm sorry. Then we're dividing both sides by 2, and we have x is equal to 7. Excellent. Next one. So this one is going to be a little bit more difficult. Number 5, you see that 1/3 there? I think we're going to have to divide by 1/3, right, at one point, but how do we divide a fraction? Turn to your neighbor and remind him, how do we divide a fraction in math? Okay, how do you divide a fraction, everyone?
Multiply by the reciprocal.
Good, we multiply by the reciprocal. Let's all repeat that out loud. How do we multiply a fraction, everyone? Okay, good. Let's see you work this one out, and I'll check up on you in about 30 seconds. So the answer here is, if we subtract 9 first, you get 1/3 x is equal to 12. And then we have to multiply by the reciprocal of 1/3, which is multiplied by 3 over 1 on both sides, you see? On this left side, they both cancel out, right? And leaving just x. Right side, 12 times 3 over 1 is just like saying 12 times 3. What's 12 times 3? 36. Okay. Or 36 over 1, which is just 36. Okay. Ready? Number 6, last one. Go. By yourself. Again, x is equal to 5. How did I do that? I used the addition property of equality, added 7 to both sides, divide both sides by 4 using the division property of equality, and then you got x is equal to 5. Okay? Good deal? All right, so we're done with that part of the lesson. What I like doing now is have you talk. We're going to answer these out loud, and we're going to volunteer these answers, and I'll call on you also, but I need you to prepare them. So talk in your groups, these 4 questions. What did we learn today? How do we do that? How does this fit in math, and how might we use this in real life? Ready, set,